And here we are on part 5, which we are interpreting the derivative from graphs and tables. So here we have 3 graphs, and you're told that f of t is the vehicle's distance from the starting point. Now, which one could be the derivative, meaning we'll give the velocity of the vehicle moving along the road on each of these graphs? So the first option is a bus on a popular route with no traffic. Well, in that case, it's going to be 2 because the bus can accelerate, no traffic, but then it has to come to a frequent stop where it lets people on and off. So popular route means that it's stopping a lot of times. So we accelerate, the velocity increases, velocity decreases, bus stops, velocity increases, decreases, bus stops, etc. So A goes to number 2. Next, a car with no traffic and all green lights. Well, that's number 1 because the car starts and then just keeps going at a constant velocity. So B goes to number 1, excuse me. And then last, a car in heavy traffic conditions. This car is going to be starting and stopping and speeding up and slowing down. So the velocity will be increasing and decreasing. So that is 3. All right, number 2. This graph is a little bit hard to read because you have years on the t-axis, and on the y-axis you have a total fertility rate. This is already a rate here in average children per woman. So if you look at the slope of this curve at any point, it will be the average number of children per woman per year. So it's like a second derivative because it's a double rate. So we're starting with the rate function. It makes it a little bit more complicated to understand. So we are saying the graph of the total fertility rate is from 1940 to 1990, and they want you to first estimate the value f prime of 1950. Well, that just means take a look at the slope right here. Well, I'm going to take the endpoints of this little section, and it looks to be about 3.5 minus maybe 2.6 all over, how many years do you think that is? 1945, well, 1947 to maybe 1955. So 1955 to 1947. And I end up getting 0.9 over 8, which is about, I think what the key said was 0.1. Let's take a look at that. When I put this in my calculator, I get 0.11. So of course, these are estimates. Your key says something slightly different than what I have, but that's fine. So you would do the same thing at 1965. It gets a little bit more complicated because this section looked linear. This section, we actually have to draw a tangent line here. I know it's going to have a negative slope, and I'm really just having to estimate. So I might have gone down by 0.5 and over by, say, 3 years or something. So if I go down by 0.5 and to the right by 3 years, that's about 1/6, which is maybe 0.167. And I see your key says negative 0.3. Doing the best I can to read a very poor graph. So don't sweat it if you're not getting this exactly the same way that my key has it. 1987 is over here. It's going to be a small positive slope. And I'm not going to go into estimating it right now. I see your key says 0.07, and that's fine. I just know it's greater than 0, but certainly less than what this one was here. Next, what are the meanings of these derivatives? Well, I've already mentioned that, is that the y-axis is average children per woman, so the slopes would be average number of children per woman per year. And so that is basically the change in the average fertility rate per year. And then last, can you suggest reasons for these derivatives? Well, this here is the baby boom. So we're getting into like sociology and history here. But around after World War II, the men came back from the war and people had a lot of babies. And it's been well documented that the baby boom occurred. That's why there's a high positive slope. In the 1960s, the fertility rate dropped off. They call it the baby bust. Frankly, I've never heard of that. And then baby boomlet, this is when the babies of the baby boomers started having babies. So there's a little bit of an increase here, but it's basically asking you to think through some of the historical and sociological reasons why these rates may have changed.